Okay, I'll give you all. I mean, nobody's here, but let me share this stream. Okay, let me know if when you get back. I'll get out of the way. Okay, I saw in the last stream that Maddie said she had some luck if she just refreshes the page on her side. Okay. Yeah. I'll have to figure out how I could record the audio separately and try to upload it there. But okay, just to recap. U is an eigenvector, right? Because when you multiply A times U, you get a scalar multiple of U. And that scalar is -4. And we call -4 the eigenvalue. Okay, and then if we try to do the same process with V, we don't get a scalar multiple, right? Because we would want lambda to be -3, but that doesn't work out with the second component. Okay. And now let's do another example. Okay, this example says, show that the number 7 of A, which is 1, 5, and then find the corresponding eigenvector. I got a pop-up that said that my connection is unstable. So if you could hear me. All right, Noah says yes. I think it will get better over the next few weeks, though, as the companies are better prepared. Okay, great. Okay, so you could at least hear me. Yeah, so we want to show that 7 is an eigenvalue of this matrix. And so what we want to do, so I'm going to just kind of tell you what to do, but I want you to try this on your own first, is try to solve the equation AX equals 7X. Okay? And another way, so I'll write out the first step. We can subtract over the 7x and treat it as the matrix A minus 7I times x, I being the identity matrix, equals 0, right? And we know how this is a homogeneous system, so we're really good at solving these. You just get a matrix and row reduce it. Okay, so see, I'll give you a minute to see if we can try to solve this. And then maybe write in the comments if you had any luck. You don't have to write out the answer because it could be, no, the answer should just be a vector, 2 entry. So if you get an answer, feel free to share it in the comments. Or type IDK if you're not quite sure. Just so I could get an idea of what pace I should be going at. It's kind of tough not being able to see anybody, right? In class, remember, I would walk around and kind of get an idea of how everybody's doing. Today, it's just silence. Noah, there could be 2 answers. I don't think there are. Let me check. The answers. But the answer is a vector, so there should be 2 components to it. Okay, let me work it out. See what we have here. Yeah, Taylor, that looks right. Yeah, exactly. So if you want to look at what Taylor says, just so you have an idea of what the answer will look like. But let's see how she got there. So we want to solve AX equals 7x. And I'm saying that's the same as looking at the matrix A minus 7I times x equals 0. So let's look at what A minus 7I is. A was given to us. Seven I is just 7 times the identity matrix. So it's just 7s down the main diagonal. And so this is the matrix minus 6, 6, 5, minus 5. Okay, so you see how I did that? I took A minus 7I. The 7 came from the example that was given to us. You could imagine down the line, we're not going to be given the eigenvalue. We'll have to figure that out on our own. But for now, let's say we were given our eigenvalue. We have this. And now what we want to do is set up an augmented matrix and row reduce it until we could find a solution. Okay, so we want to solve this matrix times x equals 0. The way we do that is we set up the matrix 6, 5, 6, negative 5, 0, 0. And we row reduce. And it works out to be this. Which is saying that x1 minus x2 equals 0. Or another way to write that is x1 equals x2. So any vector of the form a number times the vector 1, 1 is an eigenvector here. Shutong asks, how did I get the matrix 7, 0, 0, 7? That's 7 times the identity matrix. Okay, and the identity matrix, remember that's the matrix that has 1s down the main diagonal and 0s everywhere else. And so when you multiply it by 7, all those entries on the main diagonal become 7s, and everywhere else still stays as 0. So I'll do that calculation down here. So 7 times the identity works out to this. So this is 7 times the identity matrix. So why are we using the identity matrix? We took this matrix equation here, ax equals 7x, which we don't really know how to solve. So we just rewrote it. We rewrote it as and we're experts at solving those. Yeah, so what does it mean? A minus 7 equals A minus 7. Like it, what you wrote there, Shutong, doesn't quite work, because that'd be like a matrix minus a scalar. I mean, sorry, a matrix minus a vector, which that doesn't, remember, in order to add or subtract matrices, they have to be of the same dimension. So we want to have a matrix minus a matrix in order to do that calculation. Any other questions? Okay, so this theorem we're about to state, and I'll get out of the light here so we don't have a shadow, gives us a way to find, or gives us a way to start to figure out how to find eigenvalues. Lambda is an eigenvalue of A if and only if the equation A, if and only if this matrix equation has a non-trivial solution. Okay, and so this is going to be how we find the eigenvalues. We're going to look at the matrix A minus lambda I, where lambda we're just going to treat kind of as a variable. And we're going to figure out what conditions must be satisfied in order for there to be a non-trivial solution to this equation. So for instance, we could look back at the invertible matrix theorem and just pick one of our favorite of the 15 different. Okay, so let's write another definition, and then we could look at an example. Something to note here before we write the definition: there are many eigenvectors for this eigenvalue, but they're all just scalar multiples of each other. Okay, and in general, we're going to see that they're all just linear combinations of each other. And while I'm doing this, feel free to type in questions. I'll try to answer them. And if I'm going too fast, slow me down. Like if it's breaking up a lot while I speak, just let me know, and I'll try to repeat myself more and talk slower. Called the Eigen Space. of the matrix corresponding to lambda. Yeah, Braden, this only makes sense for square matrices. Yeah, so all of this is we're under the assumption that A is a square matrix. If you go on to take another semester of linear, there's the idea of eigenvectors for non-square matrices, but for now we're dealing just with square matrices. Okay, so the set of solutions to this matrix equation is called the eigenspace. So in our previous example, all scalar multiples of the vector 1, 1 would be the eigenspace corresponding to lambda equals 7. Okay, so let's look at one last example. And then just a fact about this, an eigenvalue of A is lambda equals 2. So you trust me on that one. And so now the question is find the eigenspace of A corresponding to 2. Or sorry, find a basis. For the corresponding eigenspace. Okay, so does somebody want to put in the chat how they would go about doing this? And if you're unsure, you could maybe just either don't say anything or say IDK, just so I have kind of an idea of how it's going. Yeah, exactly, Taylor. So we want to find the solution to A minus 2i times x equals 0. So find those vectors. So let's just do it out now. So let's find what A minus 2i is. So A minus 2i is the matrix 2, negative 1, 6, for all 3 rows. Okay, and now let's put it into reduced row echelon form. Multiply the identity by 2 and find the solution. Yes, Miriam, exactly. Let's put it into reduced row echelon form. And we get that x1 minus 1/2 x2 plus x3 equals 0. looks like this. Yeah. And this should be a plus. Okay. Sorry. Okay. Yeah, we solve for x1. We get 1/2 x2 minus 3x3. So 1/2 x2 minus 3x3, x2, x3. And these vectors here form a basis. Okay, so another way to solve this, or another way to word this, if it's easier for you, the eigenspace corresponding to lambda is the same thing as the null space of the matrix A minus lambda I. Okay, so if you're comfortable dealing with null spaces, which we've dealt with a lot these last few weeks, this question is just equivalent to saying find the null space of the matrix A minus lambda I. Okay, I'll stay around for a little to answer any questions, but I think this is a good place to stop. Tomorrow we'll pick up with some more 5.1. And I posted a video this morning that does a question similar to this. So if you want to check out another similar type of question, it's on YouTube. Okay, see you all tomorrow. Oh, the homework is due, I think, at 11:59 tomorrow. It should say on Canvas. Yeah, tomorrow, Thursday, midnight, 11:59 p.m. Thank you all for remembering to hit the like button on your way out. Sorry. Yeah, and shoot me an email if anybody has any homework questions. I'll be on Zoom at 11 o'clock. Okay, any last minute questions? If not, I'm going to sign out.